Hello, I'm Todd Little, Chief Architect, Transaction Processing Products, and will be briefly describing how one can achieve data consistency across their microservices. In this session, I'll cover why data consistency is important and why it is particularly important to microservice-based applications. Let's look at a simple example of why data consistency is required. Jane sent $100 to Dick. So Jane's account needs to be debited $100 and Dick's account needs to be credited $100. The first part of this request succeeded, so the money is no longer in Jane's account. But for some reason, the second part of the request failed, so Dick's account was never updated. This type of problem can lead to financial losses, customer satisfaction issues, such as two people assigned to the same seat, or orders that were confirmed but never fulfilled. If the information that wasn't successfully saved was something like a signature, you could run into legal problems. All of these are essentially a problem when two or more updates must succeed or none succeed. Many organizations are adopting microservice-based architectures to gain the benefits of building applications out of microservices. Some are migrating or surrounding their existing monolithic-based applications with new microservices, while others are building net new applications using microservices. With microservice-based architecture, each microservice typically has its own database. When a request spans multiple microservices, there is a good chance that it will run into the dual write problem. In a monolithic application, the components would simply share the same database and database connection and use local database transactions to ensure consistency across updates. Unfortunately, in the microservices world, local database transactions can't span microservices. The question is, how does one overcome this dual write problem? While a number of solutions exist, one of the easiest solutions is to let another microservice worry about ensuring all updates happen or none of them happen, sort of a workflow engine to ensure data consistency across microservices. This kind of workflow is often called a transaction, which includes multiple updates, much like a database transaction includes multiple updates. But here, the updates are being done by different microservices. To manage this workflow, a distributed transaction manager is used. The advantage to using a distributed transaction manager is that it takes on the responsibility to ensure data is consistent across microservices. It does this by taking on the burden of error handling and recovery such that the microservices can focus on business logic and not on underlying technical issues. By using a distributed transaction manager to keep microservices consistent with each other reduces the complexity of the microservices. Developers can focus on the business problem to be solved instead of trying to solve technical problems. To ensure compatibility with your development frameworks and environments, MicroTx is based upon industry standards such as REST, Eclipse Microprofile Long-Running Actions, XA, JAX-RS, Helidon, Spring Boot, ExpressJS, and OpenID Connect. As a result, you can easily integrate your existing assets while creating new microservices in Java, TypeScript, or Python. All of this combined leads to faster time to market with higher quality. If you scan the QR code, you'll be taken to the MicroTx homepage. The direct link is listed if you prefer. From there, you'll find links to our live labs, documentation, blog articles, white papers, and more. Check out the download links and a quick start guide to get started developing data-consistent microservices. Thank you, and I hope you enjoyed this presentation.